Welcome to Computer Science 305. Today we're going to be talking about parameters. And so, parameters are one of the most important, and understanding how these things actually work is very important when you're talking about a language system, right? Because there's so many different ways that parameters can be passed, can be utilized. And so, prior to understanding this, we have to have definitions for some things, right? So, when we have our actual method definition, when we have the parameters that are defined as a part of the method header, we call those our formal parameters, right? They're the ones that are actually going to be utilized in the method body, and but do not define any single value for which they will hold. On the other hand, when we actually call a method, right, somewhere else, even inside of our own method, if it's a recursive method body, we call those parameters the values that or expressions that will provide value to the formal parameters. We call those our actual parameters because they're the actual value that will be provided. So this question then becomes, how are these parameters passed, right? So how are the actual parameters moved into the formal parameters? It does look pretty simple, but in reality, there's been numerous different techniques, both with their advantages and disadvantages, proposed over the years. So the basic outline of what we're going to be talking about. First off, we're going to be describing the parameter correspondence issue. So how do these things actually correspond between the actual and the formal parameters? And then we'll talk about the implementation techniques for parameter passing, and so that we have the 7 that we see there. And then finally we'll talk about some specification issues associated with different languages. This will be broken down into probably 3 different parts, one for the intro at this current part right now, as well as parameter correspondence, the implementation techniques, and then specification issues. So parameter correspondence, right? It's basically the question, as it says here, is how does the language match up parameters? So if I have a method call with all of its actual parameters, how do I connect those to the formal parameters defined within the actual method definition itself? So the most common approach is using what we call positional parameters, right? So it's a one-for-one lineup of the actual parameters in their order that they were defined as formal parameters, and then that's how the actual parameters get copied in. On the other hand, we can also use keyword parameters, right? So if we have, we can use parameter names, and order doesn't matter anymore. We just use the parameter names to provide the values, right? So as we see here in Ada, you can do this, where we have some divide method that takes in a dividend and a divisor in either order, as long as we give it the name, and we can assign the values, apparently x and y, right? So we're matching the actual parameter x to the formal parameter dividend, and the actual parameter y to the formal parameter divisor. As I noted, parameter order is irrelevant when you have this going on. Furthermore, we can also mix and match these 2 approaches, right? Most languages that support keyword parameters allow both positional and keyword. So these include like Ada, Fortran, Dylan, Python, Groovy, and a few other languages. The note is that the first parameters in a list can be positional, but the second you start using keyword-based parameters, the rest have to be keyword. You can't mix and match. So you can have positional, you can have all keyword, or you can have positional followed by keyword, but you can't go keyword then positional. Otherwise, the language system will get confused and have throw some runtime or compiler errors. Another issue is that you can have optional parameters. So basically, optional parameters are they're not. It's not that you can just define the method to not have, or the call on the method to just not have values. Rather, what you do is you provide default values in the formal parameter list to be used if the corresponding actual parameter is missing. So this gives a nice way, a shorthand route of creating overloaded methods. For example, in Java, as I'll talk about in a second here, you can't do this, and so you have to go the long way around, and I'll talk about that shortly here. So if we have C++, right, as we can see here in the definition of the method f, we have for each of the individual formal parameters, we have we set them equal to some value, and that's setting the default value for that parameter. So in essence, we can we have 4 potential options that we have for this function. We can call it with no parameters, and then it's the same as calling f123. If we call it with only a single parameter, that's the same as calling f with a value for a, and then the default for b and c, 2, 3. And then if we have 2 parameters, it gives us whatever those 2 values are for the first 2 parameters, and then a default for the third. And then finally, obviously, we have defined a, b, and c. Now note, if we were doing this in Java, we'd only be able to write it in the way that we see in the bottom half of the screen here. Why? Because it doesn't allow default parameters. It only allows us to override existing or overload methods. In other languages, there are times when you can actually have default values for multiple parameters, but only when you are naming them does that work out well. So in other words, if you define a default value for one parameter, then the rest of the parameters following that must have default values as well. For example, if you tried in this case to give it a value for A and a value for C, but you did not provide one for B, it will assume that you meant A, B, and then a default for C. So bear that in mind. Furthermore, we can also have unlimited parameter lists. So some languages actually allow the actual parameter lists to be of unbounded length. For example, C, C++, scripting languages like JavaScript, Python, Perl, Java, Groovy, Ruby. I think pretty much most modern languages allow this. And then you have to have some way of accessing the excess actual parameters, right? And so this provides a hole in static type systems, since the types of the excess parameters cannot be checked at compile time. Typically what actually happens is in languages like C#, Java, and I want to say Groovy, the way this actually works is the formal parameter is defined, for example, instead of as we see here in printf, right? We have a triple or an ellipsis, triple dot, ending the parameter list in the formal parameter list. In Java, we have to actually give that formal parameter a type, so it'd be like string, triple dot, and then a name, like names or something like that. And so that variable names is actually an array object that we can then access, but we know the type. So if you're going to do this in most static type systems, it requires you to provide a type for that that last parameter. So you can have as many parameters as you want at the end, but they just have to be of some type. If you want it to be, we'll say, of an unknown type in Java, you can actually just use object, and then you have to check at runtime what type of the incoming parameter was. Other languages like Groovy, which have dynamic typing, you can it basically boils it down to where you just make assumptions on the type and its object if you can't figure that out. So anyway, okay, so that ends this first half, or this first part, and we'll pick it up at the implementation techniques in the next video.